Hi, Ms. Jacobson.
Hi, Mr. Dory.
How are you?
I'm very well today. I'm very excited.
I am too. You know why I'm excited? I've been thinking about triangles all day.
Oh, so have I. There's so much to say about them.
There is, in fact, take a look at this. I was doing some research on triangles,
Yes.
and I found out that you can classify them based on the sides of the triangle.
Oh, fantastic.
Take a look at this. If we have three congruent sides, we have an equilateral triangle. All three sides are the same length. If we have two congruent sides, two legs that are the same length, it's an isosceles triangle. And if all three sides are different, we have a scalene triangle. Isn't that so cool?
That is fantastic. What a great way to categorize triangles.
I thought so too. It's my favorite way.
Oh, I love that. And great visuals on really identifying how they actually look. Wow.
But some people don't like doing it by the sides.
That's true. And actually, I'd like to share with you some things that I researched to do it a little differently.
You have a better way?
I do.
Oh, let's take a look at that.
Well, actually, if you have triangles by angles, one other way to look at it is to really label them by a name. So, the first one is acute. And acute angles are all angles less than 90 degrees. So, acute, think of smaller, less than 90 degrees. The next one is a right angle, and that one would be 90 degrees. Right angle, 90 degrees. Then we have obtuse. An obtuse angle, one angle is greater than 90 degrees. And finally, we have an equilateral, where all angles are congruent. So what do you think of that, Mr. Dory? Another way to look at it.
I like that. You know what the obtuse makes me think of with a big O? Something that's really fat.
Oh,
Like a big triangle, giant angle. That's
love
what that makes me think of.
That's so great. That's a great way to remember it.
I think so too. You know, you can do a lot of stuff with right triangles. You can use the Pythagorean Theorem. Do you know the Pythagorean Theorem?
I've heard of it.
It's
Oh,
awesome. This is my favorite theorem.
well, tell us
of the
more
day.
about it.
Well, take a look here. If we have a right triangle, remember a right triangle has one 90-degree angle, we have the two smaller sides that are called the legs, and the large side that's called the hypotenuse. And we call the legs A and B. The hypotenuse, the big side, is always the C. And if we have a right triangle, then A squared plus B squared equals C squared. If I take the length of the small leg here and square it, in the length of the other leg here and square it, that's going to add up to the same number as if I take the length of the hypotenuse and I square it. You can't beat that.
You can't. That's fantastic.
Pythagorean theorem, it's pretty useful. You know, you can use it if you want to find the length of one of the sides, like if one of them is missing, you only know two of them. It's pretty useful for that.
Fantastic. And then really when you're done, you can either leave it in radical form or not, depending on what the question's asking.
That's true. I like radical form. It's more exact.
I think so too. I do like it.
Yeah.
So that's great. So two legs and hypotenuse.
But
Great.
you can do more with it.
You absolutely can do more with it, which is very exciting. That goes back to the right acute and obtuse triangles. So here we go again. So I'm going to let you continue with that Pythagorean theorem.
Well, check this out, Ms. Jacobson. Here's what I learned today. If C squared equals A squared plus B squared, we have a right triangle. And if we have a right triangle, A squared plus B squared equals C squared, it's like a biconditional. But this is even cooler because I never knew this about right triangles. If C squared is bigger than A squared plus B squared, the triangle is obtuse. If C squared is smaller than A squared plus B squared, the triangle is acute. So if C squared is smaller than the other two, then it's acute. If C squared is more than the other two, then it's obtuse.
You know what's fantastic about the way you showed that?
What's
This
that?
is awesome. I mean, this is great, first of all. I didn't know this, and you just showed me so much about this. It looks like this is a less sign. And since acute is a smaller triangle, less than acute, less, little. But this is a greater than or large, like you call obtuse, a fat triangle. That might help remember that larger or greater than is obtuse.
That's really helpful as long as you put the C squared in the front. you
Yes.
can do it that way. It's pretty helpful.
That's great.
It is.
Great. Wow, what else? There must be more to
Oh,
tell.
this is really good too. In fact, this I think, Ms. Jacobson, is one of your favorites, isn't it?
I love this. Oh, this is one of my favorites. The
Well-
PAP. So, can I explain
Oh,
that?
please, certainly.
Wait till you see this. This right here is called ratios involving right triangles. Now here we have an altitude drawn, and we also have, oh, look at this, the bottom is broken into piece 1 and piece 2. You use this formula, P, piece 1, over altitude, equals altitude over piece 2. Well, gosh, if I'm trying to find out the altitude of this triangle, and I know this piece and this piece, I can plug it in and find out what the altitude is. I will always, Mr. Dory, use this formula when I'm working with altitudes. Another thing about triangles.
But what if I want to know one of the pieces? What if they give me the altitude, Ms. Jacobson, and they give me one of the pieces, but I don't know this one? What do I do?
Oh, fantastic. You plug in the altitude here and the one piece and solve for piece 2.
Oh, that's it?
That's all you do.
Oh, I can do that. That's not bad at
Absolutely.
all. But I have another question.
Yes.
What if I'm working with the leg? Like, what if I don't care about the altitude? What if I only care about the leg?
Oh, well then we have to go to a different formula.
Oh,
Yeah.
what is that one?
Yeah, you cannot use PAP if you're not looking for altitude. Oh, and here it is.
oh,
Yeah, right here. So you're right. If you're trying to find the leg of a triangle, you're absolutely right, Mr. Dory. What do we do? Well, we have to use a different formula. This leg is one piece. We're going to label that L. And now we have the whole bottom, which is the hypotenuse. I think it's a good idea to label that H.
oh, that's the hypotenuse of the big blue triangle.
That's
So
correct.
the big one. So that's that giant hypotenuse across from there. I
That's
see what you're
right.
talking about.
Absolutely. And now, well, here's the altitude, but guess what? We don't need the altitude. We really want to find out a leg. So you have one piece here, and you have the hypotenuse and a leg. All you have to do is use help. Hypotenuse over leg equals leg over part. And when you put them together and feed in the pieces, the numbers, you will find out what that leg is. Or if you know the leg, and if you know both legs, and you're looking for the hypotenuse, you can do it with the part and fill it in that way. So either way, as long as you have 2 of the 3 pieces, you're okay.
And I noticed that you have the piece, is the piece that's in the same triangle as the leg.
That's very
Is that always true?
important. Always true.
So like if it's the leg over here, I wouldn't use this piece.
Absolutely not. You must always use the piece that's next to the leg that you're working with.
Gotcha.
Yeah, this side of the triangle really is not important for this leg piece.
Wow, there's a lot to this.
Yes, oh, absolutely.
Is there anything else we should talk about today?
Yes, I think there's a lot more.
Well, what else can we add here?
Well, I think at this point, we should stop and digest all of this, and let's have a conversation about it, discuss it a little bit, and in our next video, we will move on to even a greater topic.
Is that possible?
I think it might be.
Well, you know what, Ms. J? There's one thing I just have to talk about. I'm so excited.
Ah!
I have to talk about the exterior angle theorem.
I see.
It is so much fun.
Well, that's
that-
outside the triangle.
Yeah, but let's think outside the triangle for a moment.
I like it.
Okay? One last thing, 'cause I really like this. The exterior angle theorem is very simple. It says that this exterior angle is equal to the sum of these 2 angles that are across the triangle. So if we have a 10-degree angle and a 20-degree angle, that adds up to 30. This angle out here also is 30 degrees. That's the exterior angle theorem.
Oh, wow. So an exterior angle always is the sum of the 2 non-adjacent interior angles.
It is. It's the ones right across it. You have to go right through the
Oh.
triangle to get to.
So
That's
this
the
one's
joke.
called. This one's called adjacent, so we
Yeah,
can't
this one
use
inside
that.
is adjacent.
Oh,
We
okay.
don't want that. We don't want them to be next to their neighbors. We want them to be detached
I
and
love
part of it.
that. Wow.
And so Yep, so add these two together, it's the same as this one.
So I guess it really was important to have that be part of the triangle
It was,
discussion
I couldn't
today.
possibly not talk about it.
Yeah, I know
But,
how you
yeah,
are with it.
I know, it's the Mountain Dew.
Oh, absolutely.
Well, I guess that's all I have to say for this time. What about you? Anything else,
I
Miss J?
think that really wraps it up for triangles.
Well, it was fun. We should do this again.
I think so. Thanks for joining us for Triangle Properties.
We'll see you next time.